All right. Hi, everyone. I'm Tim. I'm really excited to be here. This has been a wonderful conference. It's been my first time at RubyConf Taiwan, my first time in Taiwan altogether, and I really hope I can come back again. But until then, it is my great pleasure to bring this event to a close with some final thoughts about Ruby. But first, let me introduce myself. So I work at BuildKite. We make fast, flexible, and secure CI/CD and more, and we do all of that with Ruby, which is super cool. And I also work on a range of Ruby open source projects. And since we'll be covering these today, I would just like to introduce them to you now, one by one. So first we have Hanami. Hanami is an app framework for Ruby. We can use it to build web apps, APIs, or really any kind of apps. And actually, just on Hanami, I was delighted to learn about Matsue City's support of this event and the peony flowers that form a connection between Taipei and Matsue. And this resonated deeply with me because Hanami, this project I've worked on for many years now, also features blossoms as the way we present ourselves to the world. You'll see these when you come straight to our website, and we're invoking the Japanese meaning behind our project name, literally flower viewing, and in practice, the custom of enjoying the transient beauty of flowers. Now, I love talking about Hanami, and I was honored when Mufan asked me to come here and share with you all today. But truly, I didn't expect him to go and create a whole airline brand just to welcome me. I was touched. So that's Hanami. We also have DryRB. With DryRB, we provide a range of standalone, focused Ruby gems to help solve the common tasks we all encounter when building apps with Ruby. And Hanami is implemented using several of these DryRB gems. And then last we have ROM, which is a powerful, flexible, standalone data persistence toolkit for Ruby. And yes, it works with SQLite. So all this talk we've been having this event about milestones, 30 years of Ruby, 10 years of this event, and along with Ted's wonderful tour of the history of the web this afternoon, well, it got me thinking about how I got here. Because I've been working on these projects since 2015. And this work didn't come out of the blue. There was a long time coming. And it really came after I'd already been working with Ruby for a long time. So my time with Ruby dates back to 2001, in fact. And time really does fly. 2001 is a long time ago now. And in such a long time, some things changed and some things stayed the same. For instance, here's a picture of Matt I found delivering a talk back in 2001. And well, here's how he looked yesterday when he opened the keynote. I don't know how this is possible. Maybe I need to become a programming language designer. But as for me, I went back to time, and here is baby Tim for all of you to see. This is around 2001. And yes, I have aged somewhat since then. And 22 years have passed since this time. And this year, I have turned 39. So this means I've been using Ruby for well over half my life now. And it's a truly great time. So continuing down memory lane, I did go and find and code to my very first Ruby project. Now, this was a time before Rails. It was a time even before Ruby gems. And my first project wasn't about the web at all. It was an IRC bot. And back then, I had a group of friends whose hobby was making these things in completely inappropriate languages. And yes, I might have been young at the time, but I already knew then that Bash wasn't for me. So I went looking around and I found this thing called Ruby. And it did look nice. So I gave it a go and made my own bot. And now, looking through the code today, it really does feel like a strange relic from another age. From the little things, like the way I just chose to camel case my file names, to the perhaps more egregious things, like building a plugin system out of global variables. Although I did learn yesterday that's how maths got started, so maybe I can give myself a break here. And then we have just the really strange things, like the complete absence of empty lines in this project. Yes, every class looked like this with no white space whatsoever. And this fixed me we see here? Yeah, that makes me now old enough to have come along to the party last night and enjoyed a nice Taiwan beer with us. So anyway, I think I've come a long way from this little 11-file application, that's for sure. But the amazing thing is, some 22 years later, I'm still using Ruby, day in, day out, and I'm still loving it too. So really, I think there is no better language to accompany someone in their journey as a programmer over all the years. And that's what I want to share with you today. Some thoughts from a life lived with Ruby from past to present. And to do this, we're going to have to tie together a whole bunch of threads here. But I think I found just the right way to do this. So just give me a minute to set the stage for you. All right. Are you ready for a journey? It is a golden age in the land of Rubyist. After enduring years of unrest, the compatibility crises of the 1.9 epoch, and the roiling dramas played out across many impassioned comment threads. At last, the citizens of Rubyist have arrived at a time of peace and prosperity, this golden age. Thanks to the dedicated oversight of Lord Mats and the Knights of RubyConf, the villages are thriving and the harvests well managed and bountiful. With every passing cycle, new facilities are built, designed, and spread across all the lands for everyone to enjoy it. Most of the pockets of trouble have been destroyed, with the only remaining hazard to the wayfarer being the occasional stray band of marauding bugs. Most of the lands have been mapped, though some unexplored regions still remain. Yes, I think the perfect avenue to explore this golden age of Ruby is a big open-world computer role-playing game from its very own golden age, in this case, 1985. Now, because today we'll be playing a game set in a golden age, we have no big evil arch-enemy to defeat. Instead, our quest as the Rubyist is to exemplify the good life, to find and master the virtues of the Rubyist, and in doing so, help create a better future for everyone. So as we go through this game together today, we're going to be doing two things. Firstly, we'll be figuring out what steps we have to take inside this game, and then see how as Rubyists in our world, we can follow these same steps to make a better future for ourselves. Just checking, you can still hear me all right? Great, okay. So, some of you might have realized, if you're astute or as old as me, that this game world is based on Ultima 4, the classic role-playing game by Richard Garriott. But, if you're not familiar with this style or with this era of gaming, that's okay. We'll be talking a lot about Ruby. This game will connect the threads. And so I hope you can sit back, relax, and enjoy this journey. And between you and me, I think we'll find a way to win. So let's get going. The first thing is explore the world. To understand the landscapes, and the people who are all victims. And dialogue is one of our most important, because through dialogue that we discover the things that we get to experience. This is how we learn what role we have to play in part of this ecosystem. I don't know what that is, but let's just blame it in gremlins in... I don't know what that is. what does this mean for us, the Rubyist? This is active observation around us in this community. I think my mic's gone again. Anyway, I'll just talk loud, and if talk loud, let me know. This means observing. Attention to this. This means reading blogs, following newsletters, media, and conference talk. These reveal not just what values and the community. One simple trick. 2023. Recommend you subscribe to short Ruby newsletter, weekly resource that going on. I wonder if hello. Pretend this. Now, a moment of Ruby and 15. The way I saw, and I only came to follow some Rubyist doing interesting things. And now from here, going around us too. Back on work. It was given and I was just a click away from seeing his profile on GitHub, where I could see those ideas being played out in concrete code, which I could then go and explore for myself. It's not even doing anything. Look, they didn't have microphones back in my time, so... So after all of this observation, all of this watching, well, there's one thing left for us to do, and that's to close the loop, to reach out and engage with the people that we want to learn from or work with, because it's these smallest constructive steps that make us real part of this community. Now, for me, that meant sending a single email to Peter saying, hey, I like what you're doing. Can we talk about it? And that led to a long and fruitful collaboration. Because at the root of it, programming is a collaborative social activity. For our work to really make a difference, it has to happen in teams, in communities, in a society. And that's why we're leading with these points today, because the skills to work fruitfully in a society are the foundation of a happy programming career. These are skills that are worth focusing on and practicing. And in the Ruby community, we already have some key principles to help guide us. We start with -1, Matt is nice, and so we are nice. And then we've seen more grounded tools like the contributor covenant arise, things that can make our online spaces safe and welcoming. And what these stand for is what makes the Ruby community special. And Matt is right to say the community is the most precious treasure of our language. It's why we're all here. So these things are worth remembering as we interact with the others in our society day to day. Now, back in Rubinia, we're starting to get some idea of how this society works, and we're continuing our explorations. And, whoa, what's this? It looks like we've been confronted by one of those nasty bugs. But that's okay, though, because as the Rubyist, it's our job to find and squish these bugs. To do this successfully, however, we need to get to know our equipment. And here we reach the first of several technical exercises for the Rubyist. And we start with one of the most important, understanding the purpose and the danger of one of Ruby's most fundamental pieces of equipment, state. So when we think about building things with Ruby, we think about objects, right? With every object being an instance of a class, like this one here for a new entry in our player's log. And since this is a brand new entry, let's go ahead and assign some attributes, a body and a date. We'll save the thing, and with that, we've done the first steps of building a new app, and everything's looking pretty good, right? Well, there's one thing at play here, and perhaps it's easy to gloss over because we take it for granted as a feature of Ruby, and it's how we worked with this entry's state. And it's what we've done in these two lines here where we've mutated the object state. And these two methods are what we call attribute writers in Ruby. And behind the scenes, what they're doing is assigning or modifying that object's instance variables. And these instance variables are what make up the object's state, the values that it stores and manages internally. And when we modify these variables after an object's already created, well, it means it's possible to change the state of any one of these objects over time, which is what we call mutable state. Now, I know we're going over some basics here, but the basics are important, as important in Ruby as they will be for our quest in Rubinia. Now, in a simple scenario, this will play out just fine. But we all know that nothing stays simple for long. And what I found is that too often the unwanted complexity or the sources of bugs in my app came from objects like this, objects that play two distinct roles. That is, objects that be also behaving as objects that do. Our entry is one of these objects that be because of the attributes that it holds, like its body and its date. Objects like this exist to hold the data within our system, and we'll also often name them after nouns. But in this case, the entry is also one of those objects that do, because of the methods it has that enact change by virtue of mutating its own state or triggering side effects. Now, some might argue that these roles combined are in fact a foundational aspect of object-oriented programming. That is, the combination of data with behavior. But even with the very best of intentions and good encapsulation, this approach still combines our object's behavior with the notion of time. So this means that to truly know a system, we need to know every possible combination of objects and all their possible permutations of state in the lead-up to any given moment. And I'm sure anyone here who's dealt with a large Ruby app has felt some of this challenge. And this goes to show how a single design decision, like relying on mutable state in a place like this, can lead to larger challenges when you play it out across an entire app. So let's see where we can go from here. How about if we took those two roles and unbundled them? We could start by making it so that our player log entries are simply objects that be. We could even just model them, for starters, as plain data structures. And then for the objects that do, we could create a new dedicated class for creating entries. And in this role, our class here defines absolutely zero internal state, no instance variables at all. And with this change done, we can now run this new arrangement of the code and see that we've achieved the same outcome as before, just with some added benefits. This arrangement is now much simpler. There's no more mutation, and each piece of code has less work to do. So I think we'll have fewer bugs because of this. This arrangement is also easier to test because we can just follow one straightforward approach. Given a certain input, after we do our work, do we get the output that we expect? And we've also ended up satisfying one of the most helpful object-oriented design principles, that of single responsibility. Create entry now has only one reason to change. And we'll realize here that if we want more behavior in our app to deal with entries, well, we can do that by adding other single responsibility classes around the one we have here. So I think we're in a much better place now. And it all came from this idea of separating objects that be from objects that do. And you know, if you think about it, another good name for objects that be is values. And perhaps as a name for objects that do, we could use functional objects, or maybe just functions. So to replace that single combined entry class that we had before, we've wound up with separate values and functions. And while we began this exercise talking about the foundational building blocks of object-oriented programming, well, we've ended up at something that looks a little bit like functional programming.
But really, what we've arrived at here is the beginning of a style of Ruby that blends both object-oriented and functional programming styles. And this blend still feels easy and natural because Ruby is a flexible, multi-paradigm language. And I think it's going to serve us well here in the land of Rubinia. At the very least, we now have the right equipment to go ahead and squish this bug. Huzzah! So with this first encounter handled, we can once again roam the lands again and continue to explore. But now we know about the dangers lurking out there, I think it'd be best if we don't travel alone for much longer. We'd be better off in a group. What we need to do is form a party. And so when we visit towns and talk to people now, we'll be on the lookout for those who will join us and be part of this party. These are the people who can complement our own capabilities and almost certainly help us become better Rubyist. So what could a party look like for a Rubyist? Well, I'd like to share some folks who have been party of mine over the years as I worked my way towards doing Ruby open source work. So first we have the people who enabled this undertaking in the first place. Say hello to Max and Michael. These were my business partners for 10 years, and in this business we were building Ruby apps for clients this whole time, several every year. And after many years at this, I realized I wasn't satisfied with how these apps were turning out. And I realized I wanted to try and find a new approach in Ruby. Well, Max and Michael trusted and supported me. And that led me to Peter and then Nikita. It was Peter who gave that talk before that was so influential on me. And these two went on to become my teammates in the DryRB and ROM core teams. They're two of the smartest developers I know, and I learned so much in seeing how they go about solving problems in Ruby. And then we have Luca. Luca is the original author of Hanami. And when I joined him 5 years ago to start work on version 2, he welcomed me into the project and opened himself up to my ideas. And since then, we've both learned a lot from each other, and I think we've been able to create something that neither one of us could have done on our own. And what tells me we're on the right track are these people here. We have Phil, one of our earliest power users and a real believer in what we're building, and also Mark, who's quickly becoming the first ongoing contributor from outside our small team. So as the Rubyist, we'll need a party a little like that as we continue to go and explore Rubinia. But at this point, I might invite you to ponder, who is in your party now? Or who might you like to bring into it and work with more or learn from? And here's why the party is so important. We actually got lucky when we squished that bug before, because it was just one creature, all on its own. More often than not, we'll encounter many of them all at once. It's truly terrifying. So what we need is for our party to be around us and for our party to work together strategically. And that brings us to our next exercise. So far, we've built things only on a very small scale. But what if we wanted to express some more complex behavior, the kind that might involve several different participants working together, just like our party needs to in combat? Well, here we can take things a step further and use composition. Let's look at that code from before. Now, I called that single responsibility because it only has one reason to change. It's right there in the name. But I did kind of cheat. This is not fully working code. We totally ignored this create in DB method. So what we want now is for something to provide this behavior for us and for that something to be external. So create entry here can retain its focus. This is the job for a dependency. And to make this work, we're going to rely on our friend state here, but use this in a constructive way. So let's start by adding an initializer to our class and having it accept a single argument for an entry repo. Then we'll capture it in its state and make sure we can keep it around and use it. So now when we go back to our call method, we can create the entry in the database using the repo's create method. So with this done, we can go ahead and make an instance of create entry like this, passing in the repo to the initializer. And yes, while we do capture that in the object state, we never change it afterwards. So this means the behavior of our object will not change over time, which means we can call it multiple times over and have it work how we expect every single time. And that's composition at work, nice and simple. Instead of adding new behavior directly into an existing class, we provide it via another object and then compose the two to ensure the behavior is available where we need it. And yes, the way we accomplished this was by using dependency injection, which is a classic object-oriented technique that works really nicely with these functional style objects. And thanks to composition, thanks to this injected dependency, our class is now fully working while still preserving its focus and single responsibility. So now, having leveled up with the power of composition at our command, our party can work effectively together to defeat even the most challenging of attacks. So now we can once again continue to push the frontiers, and along the way we might encounter the unexpected, like these treasure boxes here. And of course we want to open them up and see what's inside, but we've heard tell that many of them may contain poisonous traps. So we need to be prepared for this. We need to be able to cast some spells. Spells in Rubinia can be prepared by combining reagents, special ingredients that we can buy from apothecaries in certain towns. So here we can go to the counter and acquire whatever we need. So maybe we'll grab here some sulfur ash and spider silk. And then once we have the right combination of reagents, we can use them to prepare whatever spells we desire and cast them to help ourselves out in tough situations. And you know, if you think about it, this is pretty similar to something we do as Rubyists every day, right? Going to a marketplace, acquiring items, and combining them to great effect. Does it feel familiar? Yes. We're talking about Ruby gems. And thank you to Samuel and all the team for keeping this apothecary alive for us. And one of the things that will help our Rubyists is becoming acquainted with the kind of focused, flexible, interoperable gems that express the same kind of Ruby philosophy that we've been developing so far. And we have several of those within this organization we call DryRB. So what we'll see here now is some different approaches to solving common problems in Ruby. And things might look a little bit foreign at first because of this, but trust me, each one of these things boils down to plain old Ruby. So let's take a look. We can start our tour with dry validation. Say we wanted to only create our player log entries if all the attributes were correct and only if they're correct. This is where dry validation helps. It lets us define standalone validation contracts, and we can define them in our own classes like this. And then inside, we can define our own validation rules. So for our entries, we want to make sure both the body and the date are provided, and we want to make sure their values have the right types too. And with this done, we can now go back to the create entry class that we were developing before, and we can update its call method to run the entry through the validation contract first, and then only save the entry if the contract has successfully validated our input values. So now that we're thinking about how a valid entry should look, I think it would be nice to find a better way to model these objects as we pass these around our apps, because so far we've just been using that plain hash to pass them around. This is where dry struct and dry types can help. With dry struct, we can define classes for our player log entries with strictly typed attributes. So in this case, the body here must be a string and the date must be a real date object. And these classes give us a place to go and add any other custom method we want to extend the behavior of our objects. And we can always rely on these methods working exactly as we expect, because these entries can only be initialized if all those attributes are valid. If not, we'll get an exception because it means the data is not in the right shape. And then once these entries are initialized, they're immutable. They won't change afterwards. So this is a really helpful way to enhance our values. We get the ability to add extra behavior around the core attributes, and because we don't need to worry about mutation or side effects, it means we can confidently pass them all around our app and have those parts of the code work with it however they need. So with this sorted, we can once again go back to our create entry class. And now that it can only conditionally succeed based on this validation, well, we need a way to properly express the opposite result, because returning a nil here just isn't good enough for the failure case. And this is where dry monads comes in. And if you saw Hui's talk earlier, here we have a ready-to-go approach for the kind of error handling that he shared with us. So by using dry monads, we can now wrap our created entry in a success. And now we can cover the failed validation case too, by returning that as a failure. And success and failure here are two sides of what we call a result. This creates a wrapper around our specific return values. And it means the caller has to consider both the success and the failure cases. This is good for consistency because it elevates failure handling to be a first-class concern, just as important as the success case. But it's also great for expressiveness because now we can use Ruby's built-in pattern matching with our results, like here with this case statement, where we can now match and work with the successful entry. Or we can match on the failed validation object and use it there. But that's not all. Because success and failure are both different sides of a result, we can do some really cool things with them, like modeling whole pipelines of conditionally executing commands. And that's where dry operation comes in. We're building a whole new gem to make this easy for you, and it should be ready in the next few months. Now, if you're at Masafumi's Recreating Mini-Test talk this afternoon, and you'd like to see how method added hook works in the wild, go check out the source code. Now, our goal with dry operation is to provide a batteries included approach to creating service or command classes like the one we've been building up so far. But let's go take a look at another one now. Here we have a class that's responsible for taking our player log and, if you can imagine it, printing it as a paper journal, maybe some scrolls, we'll see. Now, using dry operation, we start by inheriting from the class. And since this operation is quite involved, we're going to break it into a number of steps that we call one after the other. So we'll start by finding the entries from our player log. And then we'll print them into a series of pages. And then we'll bind them into a book before returning that book as our final result. So what we have built here is a pipeline from all these individual steps in the operation. And if every step is a success, the operation runs to the end before the success is finally returned. But as soon as a failure is returned, the pipeline short circuits, returns that failure immediately, and all the subsequent steps are skipped. And we get all of this amazing, safe, pipeline-style behavior, all while writing flowing, natural, expressive Ruby. It's truly magic. But it's not the magic we've perhaps been accustomed to being wary of as Rubyists. I think this is a good kind of magic. The magic that comes from the combined use of harmonious, small, flexible gems, where each one is approachable and understandable on their own. But these gems are also designed to be composable, just like our good app code is composable. So it means we can combine these gems in a way that suits us. And that's the ethos behind DryRB. And if any of this sounds interesting to you, we have nearly 30 gems that you can choose from. And the one thing they all have in common is that they're designed to work with Ruby apps of all kinds. So if you work with Rails, then you have a whole slew of opportunities in front of you. You can do things like enhancing your app's config with types, or leveling up your controller params by running them through a schema, building service objects in the way we've been looking at so far, using standalone validation that you can run in any part of your code and even test independently. And of course, improving your domain entity modeling with things like dry-struct. And the fact we have all these opportunities with Rails shows the power from bringing this focused, flexible, composable design philosophy to our gems. Because we can combine them in a way that suits us. And then when we leverage them together, we achieve something that is truly greater than the sum of the parts. So that's the magic. These gems are the reagents that will let us cast all number of spells. And they'll help us through whatever unexpected circumstances we'll find in Rubinia. Now, what about creating our own gems out in our world, though? Well, the good thing to know is that every gem has to start somewhere. Every one of those DryRB gems started small, and in many cases, some have remained small as well. So if you see a common pattern in your code that you could extract or publish, then I say go for it. Because every gem we make is an opportunity to level up, to practice building systems made from reusable parts. Now, the Ruby ecosystem is 30 years old, and it might feel established, but there is always the opportunity to take a look at things and offer a new and interesting take on them. Every one of us has a unique perspective to bring to Ruby, and this is worth sharing. And we have examples already of this from the conference. View component, which Rado shared with us yesterday, didn't exist a few years ago. And everything that Stephen shared before with SQLite barely existed 3 months ago. And these are fresh takes on age-old concerns. Views and databases, we've had them forever. It just goes to show that Rubyists can always find new ways to think about better constructing our apps. And this is the only way our ecosystem can continue to evolve and remain relevant, and to help us avoid that boring pitfall that Matt shared yesterday. So now, with all this experience under our belt, I think there's just one place for us to go. In our travels, we've heard that there's a dungeon that will only permit our entry once we've mastered the virtues of the Rubyist. And we've heard at the deepest point of this dungeon lies the codex of Ruby wisdom, which will foretell the future of Ruby. And you know, I think we're ready to seek it out. We've shown curiosity by paying attention to the goings-on around us and finding opportunities to engage with our community. We've shown cooperation by forming a party and working together. And lastly, we've shown cognizance by developing a working knowledge of Ruby's fundamentals, as well as establishing a collection of gems to help us better structure our code. And with that, now it's time to seek out the dungeon and tackle whatever dangers lie in wait. After sailing long and far, we found this secluded island, which looks like it contains an entrance. Shall we go in? Are we ready? Let's head down. And whoa! This is something different. Can't see a thing. Okay, I'm decreasingly... Oh, I can't see a thing. Can someone here cast a light spell? Has anyone got that handy? Well, this might do it. Oh, phew, that's better. And gosh, this is something different. This is a whole new perspective. I can already tell that a new challenge awaits us here. We need to find a way to navigate these anonymous passageways and somehow find our way to the very depths and find the codex of Ruby wisdom. And between here and there, we're going to need all of the tools and skills we've developed so far, because these dungeons present a whole new level of challenge. We have magical fields that will send us to sleep with nary a touch, and a whole slew of monsters we've never seen before. Come from. But in our journey so far, I think we've definitely built up a strong toolkit for this perilous new part of our quest. But at this point, I can hear you asking a very fair question. In the heat of the moment, in this unfamiliar dungeon, or more realistically, when we're facing our backlog in Trello or Jira, how are we going to know exactly what combination of tools and techniques will be right to deploy at any given moment? Well, luckily for us, some work has already begun on solving this problem. And that is Hanami, the modern, flexible app framework for Ruby. And even better, a major new version put together after these groups teamed up to form a party of their own. And Hanami 2 is exactly what we need in this dungeon, because it takes all the tools and concepts we've learned so far and curates them, wrapping them up in an easy-to-use framework experience. And this is exactly what we'll need to navigate these dungeons and find the codex. So to put Hanami to use, however, we'll need to learn it. And this is, of course, the last of the technical exercises for our Rubyist, to begin preparing a Ruby of the future. So let's start exploring Hanami by installing the gem, and then running Hanami new to create a new app. So in keeping with our theme so far, we'll call our app PlayAlong. And already at this point, we can hop into our terminal and start our Hanami dev server and visit our browser and see this lovely welcome screen. Dark mode, of course, we're in a dungeon still. And this screen gives us links to find out whatever we might need to find out about Hanami. But, well, luckily, we're all here in one big party together, so we can continue exploring directly. And we can start by checking out the app class itself. And this is nice and simple. We won't need to spend too long here today. But there is one thing to point out. And it's that all code in Hanami lives inside a single namespace, matching the app's namespace. So here we have module PlayAlong. This is the module that all of our code will live within. And then from here, we can move to our routes, and we'll see now the first step we have to take. To make our app real, we'll need to add some kind of route. And to do this with Hanami, we can generate an action. And we have a friendly generator we can run. So let's go ahead and make an action now for our entries index. And then hopping back to our routes, we can see the generator has made one for us. And this makes sense. A get request to entries will take us through to our index action. And here's the action the generator made. And this is a basic starter action. And actions in Hanami are the things that are responsible for dealing with our app's HTTP interactions. And we have exactly one action class per endpoint. And it's this handle method that's the most important part of each action, because that's where we tell it how to behave. And we can see here that we're given these separate request and response objects. And we can use these for doing things like inspecting the request params or setting the response body or its status. Now, speaking of those params, actions support flexible param validation schemas. These can ensure those params meet our expectations, both in terms of their structure and their types. So since this is an index action, we'll go ahead and add an optional param here. This one here being for a page number. And we want to make sure this one is an integer and is greater than 0. Now, if this syntax looks familiar, then yes, it's because it's built upon dry validation, one of the gems that's already in our toolkit from our travels so far. So we can see here that actions give us a range of helpful features for dealing with the HTTP layer in our app, including rendering a view by default. So let's go check out the view now. And just like actions, every view in Hanami has its own class. So this one here is for our products index. And here in our view, we can create exposures that prepare the values we want to pass to its template. Now in the template here, we can see that we want to use those values to prepare a list of entries, and with the body being the entry of each list item. So according to this template, we want real entries so we can actually print those bodies. But back in our exposure, we just have this placeholder array. So where can we find this logic, the job of fetching our entries? Well, to do this, we can get to know one of Hanami's most important features, and that is how our app is also a container. And a container here works as a central organizing object that's responsible for loading and providing access to all the components in our app. What are our components here? Well, they're just our app's objects. Our view is already a component, and we fetch it from the app like this, using a key that matches its name. And then what we get back is an instance of that view ready for us to work with. And the same is true for the action that we started. It has its own key, and we get back an instance. And it's via that key that we refer to the action inside our routes. In fact, any class that we put into app will be made available as a component. So in this case, let's go ahead and make a component for an entry repo, something that can return a list of entries to our view. And it could look something like this. And since this class is in the app repos directory, we'll give it a matching namespace inside player log. And then we can add a method to find and load all the latest entries from our database. And this here is using the full-powered query API from ROM, which has been refined over many years of real-world use as a standalone gem. So now we have two components in play. We have our view and we have our repo. But how do we get them to know about each other? What we really want to do is use this repo inside our view. Well, to do this, we can use Hanami's deps mixin. We can include this mixin inside any class in a Hanami app, and then pass a list of components that we want to have as dependencies. And those components become available to us as instance methods that we can use wherever we need. Now, using deps like this is central to how we can create high-level behavior by bringing together a range of smaller, more focused components. And if you're thinking this sounds a bit like dependency injection, which we mastered before, then you're right. But what we've done here is we've made it lightweight and low friction, so it's an easy path to take for us in the flow of development. And in this case, it means we can now pass the real entries from our repo inside our view to its template. So now we can go back to our terminal, and with our dev server still running, we can make a request and see our entries come back as HTML. So now we've made our first working feature with Hanami. Well done, everybody. And with this, we've managed to make it to the lowest level of the dungeon. But this dungeon is not letting up. it seems we have one last round of challenges that awaits us. And if we get past, to get past these, we'll need to learn more about Hanami, because after all, so far we've just scratched the surface. So from here, let's take a look at the testing experience with Hanami. How can we test this view that we just created? Well, like every part of Hanami, views are designed to be directly testable. We can call new directly on our view class, and even pass in a test double for that entry repo dependency. This will let us control its behavior for the purposes of this test. And after we've done that, that's already enough for us to call this view and test that its output meets our expectations. Now, what we're seeing here is a low-level, isolated test. And for most views or actions, we won't want to take things this far. A more useful approach would be to make an integrated end-to-end test, like a request spec or a capybara feature spec. And these are all available in every new Hanami app. But the thing to take away here is that because all Hanami objects are designed to be directly testable, it means we get to make the best choice for each testing situation. So now we've interacted with our code through tests, we can also do it through the console. In Hanami, we can open the console with the Hanami console command. And then when we're inside, we can use this app shortcut to refer to our app. And we can use it to access our components, which come back as instances ready for us to use. And this console always starts quickly, no matter the size of the app. And that's because we provide a lightweight boot mode that works across all aspects of Hanami Dev, from loading the console to running our tests, even to running the dev servers. So even if our app grows very large, all of our developer experiences will remain snappy all the while. Now, one thing Hanami does do whenever it boots is load our settings. These are the values that we give our app to help it run correctly in each environment. Things like keys, secrets, and flags. And we can define our settings here. Say we wanted to extend our app and have it send emails when the player adds new entries to their log. And we want to use some sort of third-party email API for this. Well, here we can add a setting for its API key and specify that we want this to be a string. And if this type syntax feels familiar to you, then yes, it's because this builds upon dry types. And we use these types here to check every setting and make sure that our app never boots into an unpredictable state. Now, with this done, Hanami would load these settings from matching environment variables. And when we're working locally, these can come from .env files as well. And after this, we can now access our loaded settings as yet another component in our app, this time using the settings key. And it comes with methods for every setting we've defined. And this will help us access the values wherever we need them. And we can do this by including settings as a dependency of any object, thanks to the deps mixin. So now we get well-formed access to our settings wherever we need them in our app. So aside from settings, so far we've only seen components loaded into our app from those classes that we define in our app directory. But what if we needed some kind of component that had special handling requirements as part of its setup? Well, this is where providers help. And we need to make one now for our email service. We've already created the setting for its API key. Well, now we need to go and use it. Providers have their own folder and config, and here we're registering an email service provider. And then inside providers, we have a couple of lifecycle steps we can work with. In this case, we're going to go ahead and start by requiring the gem for our third-party email service. And then we'll grab our API key from the settings component that we just set up, pass it in to configure an instance of this client with the right API key, and then we'll register that client instance directly in our app using the email service key. And this now means that we can use email service as a dependency in any other class, and we'll get this fully configured instance that we set up right here. So by this point, we've covered nearly everything we need to know about Hanami, but there is one more important thing for us to discover, and that's slices. Slices help us organize our app into separate domains or technical concerns, and they're a great way for introducing modularity and clearer internal boundaries to our apps as they grow. Now, you won't see them in a brand new Hanami app, and that's because we decided to keep the first run experience as simple as possible. But they are built in, and they'll appear as soon as we start putting code into the slices directory. And we have a helpful generator that we can run. So let's go ahead and make an admin slice now. This will prepare that admin slice directory for us. And then let's say we'll throw a entries create action into it. And just like our app, every slice maps to a single Ruby namespace. So here we're using admin. Hanami will then provide a slice class for us to use inside the namespace. And that slice works exactly like our app, offering access to our components. Just with one restriction, it only loads the components from inside its slice directory. And just like the app, slices have their own deps mixin, just with the same restriction. It only loads components from inside the slice. So now we've seen that both the app and slices act as containers for our components. And then thanks to our deps mixin, we can start to clearly recognize the dependencies, the relationships between these components. And this will help us start to see our app as kind of big directed graph. And then from here, we can take things one step further, because slices can import components from other slices, which means we can now envision an equally clear graph of all of our app's high-level concerns. This is a really powerful approach. Here we have the tools built right into a framework to help us better organize our code at every level for easier understanding and maintainability. Slices also give us operational flexibility, because we can choose exactly which slices we want to load for every deployment of our app. And one thing we want to do with Hanami is extend this power to apps of all kinds, not just web apps. Now let's go take a look at the gem file of a brand new Hanami app. And what we're seeing here is a web app because it includes the view, the router, and the controller gems. However, these are not fixed dependencies of the framework. That's why they're here in the gem file. So say we wanted to build something different to a web app. Well, then all we need to do is remove these extra lines. And with the one core Hanami gem that remains, we have all the quality of life features that we've just covered. We have containers, components, deps, settings, providers, the console, even slices. So this means we get to keep everything we need and nothing we don't. And we can put all these features to use for any kind of app. So in this way, Hanami 2 is no longer just a web framework, it's an everything framework. Say we wanted to build a CLI, a serverless function, a stream consumer, or even a new take on an IRC bot. But we still want all the conveniences of a full framework. Well, now we can do it with Hanami. And no matter what we build, we get a framework that encourages all the good design principles that we've been learning so far on our journey. And it even embodies those principles in its own implementation. So from my time with Ruby, I don't think I've ever seen something just quite like this. And I'm really excited to see where people can take it. So now I think we've prepared everything we need to clear this dungeon here with Hanami 2. And not only have we made it past all the obstacles, we've once again demonstrated the virtues of the Rubyist. We've demonstrated curiosity by looking at the whole Ruby framework story and the struggles we experience when building apps and asking ourselves, well, maybe there's another way. We've demonstrated cooperation by recognizing the shared ground between these Ruby open source groups and having them team up to build something wonderful together in Hanami. And still doing so in a way that provides useful utilities via all the gems to all kinds of Ruby apps. And then we demonstrated cognisance by taking all the good Ruby principles we've mastered so far and embedding them into the soul of this framework. And after we clear the last of the dungeon's rooms, we find ourselves in a long, straight corridor. Weary, but hopeful, we proceed towards the end. And, oh, I think we see something. It seems the dungeon's revealing something to us. Oh, an altar has appeared. Should we go and check it out? All right, upon the altar lies the codex, and we open it up and read. The most expressive programming language in the world is the one we hope we can get around to writing someday. The next most expressive programming language is whatever we can turn Ruby into in the meantime. These words were written by my friend Nathan Ladd, who is another longtime Rubyist, and I think it makes sense that only a Rubyist can so beautifully express both the wonder and the potential of our language. We spent our time today roaming the wide open spaces of this land called Rubinia. And for the person encountering an open world role-playing game like this on their computer in 1985, well, the possibilities must have seemed endless. Well, that's the world we have with Ruby today. The possibilities are endless. Ruby is a language that flourished and has endured because it's a language that embraces possibility. And if we embrace it back, those possibilities are ours to create. We can create the future we want to see. And as individuals, all of us, as Rubyists, we can take these steps at whatever time we're ready. As for me, it took me 15 years of just working day in and out with the language before I arrived at the right place with the right people at the right moment to discover the way I truly wanted to write Ruby in the future. And Ruby was just there, waiting for me, all along. And now that Ruby has made it to this golden age, we can be confident it will be waiting for a long time to come. So the journey is long, and we should make it ours and enjoy the ride. And I want to thank you all for taking this ride with me today. Before I finish up, I just want to share some thanks and leave you with some next steps. Firstly, I want to acknowledge all the people who worked on the things that I'm sharing with you today. So that's Luca, Peter, and Nikita, my teammates in the various core teams, and all these people below who contributed over the course of Hanami 2 development. A huge thanks I have to share to the organizers of RubyConf Taiwan for putting on this amazing event and inviting me to contribute. I also want to say thanks to ancient bards who gave me permission to use their music to set the scene for our adventure today. Really, it is an honor to be here talking with you and closing this event today, but to be able to do that while sharing three great loves, Ruby, retro games, and epic operatic metal, well, it's even sweeter. As for Ruby, I am more excited about the future than ever before. And it's thanks to the work going on in these projects. So if you're interested in learning more about any of these, check out their websites. We have some great docs. And with Hanami, we have some getting started guides that will step you through writing your very first app. Hanami has been our main area of focus lately, and I'm really excited about how things are shaping up. 2.0 has been out for a year and is seeing good use, and 2.1 is already in the release candidate stage. We'll be shipping our view layer and our front-end assets, so it's the perfect time to go check it out. Other than that, here's how you can reach me. I've had a great time meeting so many of you at the conference, and I'd love to hear more from you and about your futures with Ruby. Thank you very much.
Team Riley and okay. Wait.